Hey everyone, I'm gonna show you how to get started with Amazon Bedrock, especially for developers. So I create few very basic examples. Let's jump in. So the first example is the most basic chat and prompt, right? In here, basically, client send a question, user send a question to web servers, and then the web server gonna build a prompt. Maybe the prompt consists the entire historical conversations. It's not just the current questions, but also the historical conversations, right? So the prompt in here is like uh, user question, bot answer, and then user question, and then bot answer, and then user question, so on and so forth, right? So it's an entire historical conversation to Bedrock, and then get stream back, and then I stream back, right? Um, the model is stateless, but each time I send entire historical conversations, so the model could understand the entire conversation from beginning. So now let's jump in and do it in code. Let me open it, and let me we'll go in here. Okay, so let me refresh it. So actually, I already create it. Now I explain. I explain first the front end. The front end is just a simple input, right? So let me show you that. Okay, so it's very simple. It's just a form with input, and I have a button. When I click the button, I call Bedrock. So what it does? Okay, so it does several things. First, I'm gonna pass. I pass the user question from this HTML component. And the most important in here, I have a messages buffer, right? So messages buffer is gonna store the entire historical conversations, and it follow the format, the prompt format. This is a specific prompt format for Bedrock Color 3. For example, Color Haiku or Color Sonnet row user, right? So I push user question. However, I want to keep the historical window only for 9 conversations, because if it's too long, it will over the window context of the model. So I give it 9 for that things, right? And then I call an API to the backend. I'm gonna implement it later on, and then I get stream, and then I patch chunk by chunk, and I update text here for front end. Uh, After I get entire response from model, I push it in messages. Messages is the historical conversations. Okay, that's it. So now let's go to the back end. In Next.js, implement this very easy. So let me show you. Implement API, call it Claw Haiku, and implement it route. So this one gonna handle the post requests from client. Basically just using Bedrock SDK, and then form the command for stream response stream, model ID, some parameters. The most important here is the messages, which store the conversations, right, from beginning. Okay, and then I get response, and I pass it chunk by chunk because it's stream, and then I yield it back to client, and that's it. This is the handle post request, make iterator, and then respond client the stream. Now let's run and see. Let's say how to cook chicken soup. Okay, and let me close it so you see how it stream. Okay, because I sent the entire historical conversations, so I can ask follow-up questions. For example, how to customize it for 3 years old girl, right? So I asked follow-up question. Oh, so it, oh, here's a tip for customizing chicken soup for 3 years old girl, right? And let's ask more follow-up question. Please explain more detail the actual flavor, right? So it can explain. Okay. So that's the most basic prompt. It means entire conversations history. That's it. Now we're gonna go back uh, and I show you the second case, second use case. Also the most basic example. So in this case, I want to do vector search. Vector search. For example, I have many PDF document, PDF, right? And I already index it in Amazon Open Source. Open Source. So you can check yourself what is the indexing, what is vector search, right? In here, I'm gonna show you how to use SDK to build this application. But basically, assume that we already index some document or PDF in here, and in the database is store many vector number like 0, right? 1.5 dot, right? So user gonna ask the questions, and then the web server gonna call Bedrock model in here Titan, right, to convert the questions into vector, and then send that vector, use that vector to query the database, and then get back some vectors. So in the step 5, the response include vectors, for example, the top 10 most similar vectors to the query vectors, and also it includes a chunk of text. Okay, so let's how to do it in code. Okay, so let's create another front end. This time I create it, so let's say in here, so I create another one. I call it Amazon Open Source Server List. Let's create a page, right? Okay, that's the front end. And for the back end, I also create for the back end CD app, CD API, right? MKD AOS Amazon Open Source Server List, AOS touch round.ts, right? Okay, so now let me update the front end. I'm gonna copy from my code, so let me copy it, open source here. It's a simple front end, so paste, and I save it, and let's see AOS. It's a very simple front end, right? And let's see. Okay, so now when I enter, it will call a post request to API AOS. So we need to implement this API. We implement the backend in here, right? So this route. Okay, let me copy it route. Okay, so let's go a bit reverse. So first I'm gonna pass the request, right? I pass the user questions, and then I query open source and I respond. So let's see how does that function work. So here, right? So first I'm gonna convert the query into vector using create embedded vectors. This actually called Bedrock Titan model, and I get vector, and then I form the body for the query. I want to get the top 5 most similar vectors. and then I call the open source client, and then I get a top 5 documents, and then I return it. Right, let's see what is a open source client. So the open source clients with credentials, you have to check it yourself, but basically it will sign signature v4, authenticate to the open source client endpoint. This one gonna convert user questions to vectors using Titan model in Bedrock. Okay, so now let's ask a question. Because I already have some documents in my database, so let me ask what is Amazon Bedrock. So I expect it return me several chunks of text, right? Several chunks of text. Add let's see, is that working or not? If it's not working, so I need to check. Oh, so let me check the some sort of export name, right? So this is API, so API AOS at route. I think I have not saved it, so let me save it. And let me check the API endpoint. API AOS. Okay. What is Amazon Bedrock? Wait a few seconds because it's still compiling. Okay. So I get back some chunks. So those chunks of text are from my open source databases. One chunks, right? Another chunks, another chunks, another chunks, and another chunks of text. Let me ask another question. What is lambda concurrency? Okay. I already have those texts in my database, right? I show you later on how I upload a document and I got those chunks and vectors later on. Okay, so now let's come back the architecture. Next one. So the final one I show you the most basic rack retrieval augmented generation, right? So on the top I have knowledge base. So basically I upload a document, it go to S3 bucket, it trigger a lambda, and the lambda index, right? It index document into open source. So basically it is called text PDF file, right? It called text to extract text and chunk it into block, and then convert those chunks into vectors using Titan models, and then send those chunk text and vectors to open source. That's done. And given that knowledge base, I can be rack. So when I ask the questions, the second step, based on my questions, the server gonna query open source. So convert the questions to vectors, looking for similar vector in open source. So return similar vectors, and then also text, chunk of text. And then the servers will compose context, right? And send both user question and that context in prompt to the model. This one, context, right? And then get back answers. Okay, so let's implement it. So let me implement the front end first. So it app, I will create a new folder called rack. Rack, right? And I make pages.txt. API, I also create new folder called rack and round Next.js. Okay, so let me copy the React frontend. The React frontend are simple, very simple pages. And let me go to React frontend. Okay, the simple form input. So let's see what it does. So it just have a form and then handle submit. So in this case, I use Vercel AI SDK, this one. So this Vercel AI SDK is gonna handle the messages, right? The entire historical messages from users to the web servers. Okay, it's more convenient. And then actually when I click the button, it called an API, called API React. Now we're gonna implement this route. So let's implement this route. Let me copy my React API. Okay, so what it does, I also have a Bedrock client, open source client, right? Convert text to vectors and then looking for similar vectors in open source. So let's go back here. So I handle the post request, right? So I pass the messages from front end and then I build context. I build context by query open source, right? And then I get context and then I build prompt, right? I build prompt. So this is my simple prompt using the following context and then user questions, right? And given that prompt, the model gonna answer based on the context. So that's it. Now let's try to ask question. What is Amazon Bedrock? Does that give answers based on something, based on my document? Maybe it doesn't working, so I need to check. It's kind of working, so wait. Okay, so you see the answer based on the cost overviews provided by something. So it's based on the document I already uploaded, right? Let me ask what is lambda concurrency. Here, so what is lambda concurrency? Based on the provided lambda concurrency refer to something something, right? And let me add the document. So I'm gonna localhost 3001 and open source here, right? So I add the same question, but I query to the database. Let's see what happened. So this is a lambda concurrency, right? It gives me several chunks of text, right? So, and the models based on those chunk of text is gonna give me the final answers. Let me ask another question. What is lambda transaction per second or TPS in lambda, AWS lambda? So it always based on the context, right? Give me some very specific answer. Let me add this question in database to see. But I'm gonna okay, I'm gonna ask it here. Here you see it should have some TPC, some kind of equations, 1000 something, right? Yeah, this you see this equation, mean of something somethings, right? Mean of extend by concurrency any near mean of something. So that's how a simple rack works. And finally, I show how I deploy it and show you how I deploy it using CI/CDs, and also how I host the web server on ECS. So let me go here. So I host the web server on ECS, and I deploy this one, CI/CD, a simple CI/CDs, no blue green. So let me show you. First, I gonna show the project. So this is another project, same code, but I link this code to code commit in AWS. So let me wrap it. Okay, and let me show you the upload page. So I also show you the upload page for uploading documents and indexing. So let me upload me, right? I update this one, and I git add app upload. Okay, so now it trigger a CI/CD pipeline, and let's see in here. I got my pipeline. It should be here. Refresh it. So it trigger this pipeline, right? So this trigger could build to build the Docker image and then deploy it on ECS. Let's see detail, right? Is that chain upload me, right? So this is the upload me, right? And it will deploy to this page. The final page is bedrock.ndex.io/upload. So later on, we're gonna see upload me gonna be updated, and this page gonna upload a document to S3, and then that document gonna be indexed in the open source. That's it. So we have to wait for a few minutes, but and then deploy on ECS. Let me show you the service. So this is the service. So we need to wait for a while, and we see deployment. So that's it, and thank you.